Another second example that's just quite similar to the first, just looking for something different in this case, and again practicing our directions. Current carrying conductor placed in a perpendicular to a 0.27 Tesla magnetic field directed vertically downward has a current of 15 amps. If the wire experiences a magnetic force of 0.12 newtons west, how long is the wire, and what is the direction of the electron flow? So again, we start with a current carrying conductor. So we start with the formula Fm equal to ILB. Since we're looking for the length, we just have to manipulate this formula. Length equals magnetic force divided by current times magnetic field. Put our numbers in. We have the magnetic force. It is in 0.12 newtons. The current is given to us as 15 amps. Magnetic field strength 0.027 Tesla. Punch everything in. Don't forget to bracket the denominator. And you should get, again, to two significant digits, 0.30, and the length will be in meters. And now we'll go looking for the direction. By the way, the magnitudes, these formulas are quite easy to work with. They're not that hard to work with. They're linear formulas. You've worked with more complicated formulas than this already. It's the directions that always get students confused, or it's they forget to convert units in these cases. So again, we look at the magnetic field directed vertically downward. That's going to be into the page. The force is to the west. So if we look at this picture, you can see my fingers pointing into the page. Force is to the west. So that would tell my current should be to the south in this case. So when you go into or vertically upward and downward, that's going to mean in and out of your page. You sometimes look at the plane of your paper as north, east, south, west. And sometimes people get confused when they're watching this on the screen and then looking at their paper. But when you're looking at this in your paper is the plane that you're working on, and then you're going upward or downward from that. And you draw. That's why we tend to use into and out of the page quite frequently, but don't be surprised to see the terms upward and downward. And then the plane of your paper represents north, east, south, and west. So there's a second example. The key that you're seeing with these two examples, and something that I'm saying at the very beginning, when the conductor is perpendicular to the magnetic field, you will get maximum force. If the conductor isn't perpendicular to it, you will get a force, but it won't be as strong. And one other neat little thing, which you can see in some of the exercise questions, if your conductor is parallel to the magnetic field, there's no force at all. Once you have two of those directions the same, they all have to be perpendicular to each other. So if your current is in the same direction as the magnetic field, there will be no force.